Hello everyone. Today we are going to perform multisim experiment on diode rectifiers. The objective of this experiment is to construct a half wave and the full wave rectifier circuit according to the circuit diagram to uh, to use the oscilloscope and to work with the function generator. And after adding the capacitor, what is the effect of the capacitor on the output? So what are the sources we are going to use here? Sorry, apparatus we are going to use here are voltage supply, dual channel oscilloscope, resistors and the capacitors, and the diode. Okay, for one diode for half wave rectifier and four diodes in the full wave rectifier. And we will add the capacitor according to the required in the tabular form. Okay. So let us start with the experiment. What? So let us start the connection first. So here I am using source AC voltage source. Okay, so in the power source you have go to the power source. You have AC. We want AC power source here. Okay, and what else we need here? Just check the circuit accordingly. We need diode and the resistor and two multimeters. We need diode of value diode. Diode here 1N4007, 1N4007 family. You can take 1N4070. This one, okay. Oh, sorry. Okay. Next, we'll go to the resistor. We'll take the basic resistor here. Just you can take 3.3 kilo ohm resistor here. 3.3 kilo ohm resistor. Okay. And I want two multimeters here. Okay. One multimeter here and one multimeter here, and the CRO. You can see here, this is oscillator, this is voltmeter, this is the oscilloscope. This is oscilloscope, okay. So let us start the connection now. These are the things we require. We need capacitor also. We'll just put in last, okay. After just taking the with output without capacitor, then we will add the capacitor simultaneously. So this is power supply. This is supply. Diode here. Diode is connected here. Liquid. Liquid is here. Okay. Then what else we need here? We need two multimeters to be connected with the CR. This is positive. This to the input, and here this to the common point. Okay, and these two are connected here. Okay, and flip it again. Just keep some space here. in case if you need to connect the resistor. So here this is channel A. Channel A I will connect it to the input. Okay, this is CRO plus to plus and here minus to the minus to the common point here. Okay, and this plus to the output. Negative to this point. And we missed one thing, that is the ground element. Let us put the ground element here. Okay, so this is our circuit. We have connected this input. So let us start the circuit here and let's see, this is the AC voltage. First we have to set the value, right? So let us set the value to 24 volt. Okay, and the input should be 24. So let us see that this is input here. This is 23.994. This is input, and the output is 10 point, approximately half. Okay, so this is the DC value and this is the AC value. Both are voltages, and we have just tabulate this value in the tabular form. And this is your CRO output. Okay, so this is not proper. So what we do is we will shift this. Uh, we will increase this. This is 20 volt, and this is also 20 volt. And the position I will shift. This is for the input. This is input waveform. Okay, this is input waveform, and the position of output I will shift down. So this is output waveform. So I will take the signal shot first. So you can observe here, this is the input waveform and this is the rectifier output. The negative half part is clipped off due to that only one diode which is working in the forward bias direction. Okay, when the diode is working in the forward bias direction, the negative part, the diode in the is becoming in the reverse bias, so there is no voltage flowing through it. So that means when it is negative, you are getting 0 here. When it is negative, you are getting 0. For the positive, it is getting positive. So here we rectified. Okay, the negative part is clipped off, and positive you get only the positive part. Then what we do, we will just add the capacitor and check the effect of the capacitor on the output to make it more like a DC. So what the diode function is to convert from analog to the digital DC, right? AC to DC. So this is AC, and this is not exactly DC but half wave. Okay, so we will add the capacitor and we will check the effect. Okay, now you have to draw this part, keep it separate here, stop this, and add the capacitor here. This is capacitor. Right. Take any value of the capacitor, just put it over here and flip it. So put the capacitor here and let us see. The first value of the capacitor is 0.47 microampere. 0.47 micro. Okay, micro means you can write U and micro. Okay, 0.47 micro. Let's run this circuit. So input is, this one is the input. Here you can see. So when you add the capacitor, this is becoming like what you say, the settling time, right? The capacitor settling time is like the curve. Okay, it was not like a sharp edge here. So it is becoming exponent. It is decreasing exponentially. Okay, this is exponential flow. So for 0.47, the input is 23 and the output is 11. Stop again. Again, increase the value of the capacitor to 10 micro, 10 micro. So you can see the effect of the capacitor on the output here again. So here the settling time is increasing. Okay, when settling time is increasing, that means it is more like a DC, right? It is becoming more like a straight line. So in the previous condition without capacitor, it was like a half wave. When you add 0.47, it has become exponentially decreasing. So here the settling time is increasing, right? Not from here to here. Exactly, it is increasing like this. So when the settling time is increasing, then it is becoming more like a DC. So again, I will increase it to 47. I hope it is 47 here. 47, 47 micro. So you can see, right? So this is more like a DC. So you have to take just this outputs here and tabulate the values. Whatever for the input, you're getting some output values here. For the different values, the capacitor, just tabulate these values. So this is the half wave rectifier. So let us start with the full wave rectifier. We need four diode like a bridge rectifier. We make the bridge and wait. Close. Stop this. Close. Close this. So we need capacitor here. Just this is also. So what else we need here for the bridge rectifier? Extra things. We need four diodes. Okay. Once supply and the resistor. Same resistor value is 3.3. Okay, and the capacitor we'll use in the last bit. Same thing. So let us make the bridge here. Let's make the proper space here first. This is the resistor bridge. You can copy paste also. Okay. So now I make it like a bridge. So I will connect here input. So we will connect the input here. Just drag it here. There should be proper space here. Okay. So we connect this input here and common point here. So this we give the supply to this all diodes. Now just simple thing, connect the multimeter to this point and to this point. Okay. Then connect the resistor. Connect the resistor to this point and to this point. And connect the multimeter to this point here and to this point. And this is here, and this is common point. Just okay. Then this is output. B channel is output. So this is output. Okay. Now where is the ground? Let us make it ground here. Start. So again, let us see. This is input is 23. That means 24 approximately. The output is approximately same, right? So we are not losing any voltage. So input is 23 and output is 20 point something. So let us see the rectifier output. See here. So this is the input, and here in the previous case we were losing this negative half bulb, and it was becoming zero. But here in this case, what it is happening here, your negative half per curve, sorry, negative half sign is reverted, okay, and reverse, and it is becoming all positive, right? So let us properly shift this here. Okay, so you can draw this. Let us add the capacitor. Stop this. The same values of the capacitor. Capacitor. So first value is 0.47 micro, 0.470. So input is 23 and output is 31, and this is 47 micro, sorry, 0.47. So here you can see this is not the sharp and the flow is exponential, right? This is the flow is exponential here. So the fall time or settling time, it is increasing compared to the previous. So again, this is the output value. Again increase to the 10 micro, 10 micro. Here it is 29.8 something. So this is here the settling time is increasing. It is becoming more like a DC. Okay, the output is 29. Stop again, and this is the last value. 40. Already I think you have seen for 47. 47 is becoming very close to the DC constant, right? So here we conclude our half wave and the full wave rectifier. Okay, so full wave rectifier we use the bridge rectifier circuit. Okay, thank you.